Welcome to a practice SAT math question. In this geometry question, we're told that segment AD is parallel to segment BC. So this segment here is parallel to this segment here. Notice how these two segments are also tangent to the circle, and the points of tangency are also the endpoints of the diameter, which means angle BAD, or this angle here, must be a right angle, and angle ABC is also a right angle, this angle here. Next, we're told the length of AC is 13, so this segment here is 13 units long. Next, segment BC is 5 units, this segment here. And then finally, the length of BD is 15 units, the length of this segment here. And our goal here is to find the length of AD, the length of this segment here. It's actually going to take 2 steps to find this length using 2 right triangles. We have this right triangle here where we know the lengths of 2 sides. We know the hypotenuse is 13 units and this leg is equal to 5 units. So using this triangle, we can find the length of segment AB, or this diameter. And then once we find this length, using the upside down right triangle, or this right triangle here, we can then find the length of AD. But again, we're first going to focus on this green right triangle here, where we know the hypotenuse is 13 units and this leg is 5 units. So using the Pythagorean theorem, we can determine the length of AB, which we'll go ahead and call y. So using the Pythagorean theorem, or c squared equals a squared plus b squared, we can find the length of y. But notice how we recognize this green right triangle has a hypotenuse of 13 and a leg of 5. This would be a 5, 12, 13 right triangle using the Pythagorean triples. So the length of y is going to be 12, but just in case we don't recognize this, let's go ahead and show the work. So c must be the hypotenuse, which in this case is 13. So we'd have 13 squared equals a squared, which will let be y squared, plus b squared, which will let be 5 squared. So we'll have 169 equals y squared plus 25. Subtract 25 on both sides. That would give us y squared equals 144. We know y has to be positive, so taking the principal square root of both sides, since 12 times 12 is equal to 144, we have y equals 12. So let's substitute 12 for y here. Now we know this is 12. Let's go ahead and erase the green right triangle so it's a little easier to see. Now we'll use the blue right triangle, the upside down right triangle, to determine the length of AD. Notice how in this triangle the hypotenuse is 15 units and this longer leg is 12 units. So this is actually a multiple of the 3, 4, 5 right triangle. Again, using the Pythagorean triples, notice the hypotenuse is 15, so if we multiplied each of these by 3, we would have a 9, 12, 15 right triangle. Notice the hypotenuse is 15, the leg is 12, so the length of AD is going to be 9, and therefore our answer is B. But just in case we didn't recognize the Pythagorean triples, let's go ahead and use the Pythagorean theorem one more time. Again, using the blue right triangle, the hypotenuse is 15, so we'd have 15 squared equals a squared plus b squared. Let's go ahead and let a equal the length of AD, which we'll call x. So we'll have x squared plus b squared, which will let be 12, so we have 12 squared. So we have 225 equals x squared plus 144. We'll subtract 144 on both sides. This would be 81 equals x squared Take the principal square root of both sides, and we have x equals 9. And again, x is the length of AD, verifying our answer is B. I hope you found this helpful.